Hello everyone. Thank you for coming to the SIG Azure Intro session. My name is Stephen Augustus. I am a senior cloud native architect at VMware. I'm also one of the SIG Azure chairs. And
I'm Craig Peters. I am a program manager at Microsoft. I joined Microsoft in December, so like 6 months ago, and from doing a bunch of other Kubernetes related stuff before that. My PM as a PM role, my responsibility is sort of all the upstream dependencies that Kubernetes has for running on Azure. So SIG Azure should be right up my alley.
Yeah, so what we try to do together is, especially working from a company that's not Microsoft, make sure that we're aligned both on the company side as well as, within the community, right? So working to make sure that the stuff that we're doing is community focused and not just company focused, right?
Yeah. So we wanted to get a kind of a measure of who actually comes to a SIG Azure intro session. So I'd like to kind of ask a couple of questions, and just by raise of hands, or you can call out whatever, let us know what's going on. So how many of you have actually attended a SIG Azure meeting? That's kind of what I guessed.
How many of you actually knew that SIG Azure meetings were existed?
Yeah. Okay. Well, so that's why we're here. We're going to tell you what SIG Azure is all about and how we meet. So then the kind of next thing, how many of you are running Kubernetes clusters at all today? Okay. Right, quite a few. How many are doing it on Azure? Okay, quite a few. Not everyone. That's cool. How many of you are rolling with your own mechanisms for deploying your clusters? Okay. How many are using AKS Engine or are familiar with AKS Engine? Okay. And how many are using AKS, the managed service? Awesome. Okay. And how many of you came to get some help? Like you have some questions or concerns and you want to understand what's going on? Okay. Okay. You don't have to be shy about raising your hand. Nothing's perfect, we know, we're here to help. And how many of you came because you just want to understand what's going on? Okay,
we're gonna have a nice meaty question and answer session.
Fantastic, That's gonna be great. So
what is SIG Azure? Who are we? Why do we exist? So SIG Azure is a special interest group. The whole idea is around, obviously, managing Kubernetes on Azure. So everything that is involved in that ecosystem, whether it be provisioning, whether it be application deployment, whether it be figuring out how to do security on Azure, storage, that's kind of all of the things that we encompass within the SIG. So the SIG chairs are Dave Strebel, who is at Microsoft. My son Dave is a cloud architect, I think, at Microsoft.
He's a CDA.
Okay,
cloud
cool.
Developer.
So myself, senior cloud native. I don't even know my own title. Senior cloud native architect at VMware. Peng Fei Ni, who is one of our primary contributors to the AKS engine, to the cloud provider, and basically he touches a bunch of the things in the ecosystem. And he's also at Microsoft. And then Cal, who is one of the principal engineers at Microsoft, is also one of the technical leads. So throughout these slides, there are a variety of GitHub links that you can pop onto and get more details on how we organize.
And actually, we'll share these slides in the SIG Azure Slack, basically, as soon as we're done. So you can find them if you want any of these links. Don't feel like you have to take pictures of them.
But do take pictures.
But do, yeah. We love it.
So a little bit more about why the SIG exists, right? We're again focused on maintaining the APIs that encompass Azure and what it means to run Azure on Kubernetes. So the kind of genesis of these various cloud provider SIGs, we're moving away from a lot of what's been happening before, which is kind of cloud provider comes to the table and they say, all right, well, we're a cloud provider, we should spin up as a SIG. And moving more towards a model of how can we build a consistent process around all of the cloud providers that need to run Kubernetes, right? So whether it's the vSpheres, the IBM clouds, Azure, AWS, right? There is
the motivation behind that is really that your experience as a cluster manager shouldn't fundamentally be different if you're running it on IBM or on bare metal, you know, the cluster lifecycle should really be very, very common. There'll be implementation differences that the cloud providers then provide, but you should still have a common management model for your clusters.
Exactly, right. So figuring out how to build consistent docs, build consistent APIs around these things, make sure that the way we meet and organize is, again, consistent across all of these cloud providers, and making sure that as new cloud providers are interested in coming into the Kubernetes space, that they have a model to build around, right? So, you know, there's a lot of technical debt and cruft around the existing cloud providers, and bringing everyone into this model kind of forces each of these companies to come to the table, right, and build something for the community.
The way I like to think about it is that you know, there's a principle that your software solutions reflect the way in which you're organized. You know, it just sort of necessarily teams that work together create sort of separate monoliths, and if each cloud provider has its own SIG, then you're going to end up with very different implementations, and then that kind of leads into the next big thing that's happening, and
Yeah.
you know, why things are moving out of tree.
Right. So you know, a lot of the active efforts right now are, again, to move to kind of more of a consolidation model. So some of the active sub-projects that we have, cloud provider Azure, which is the in-tree Kubernetes provider for Azure. So it's basically you provide it a config, and it, you know, figures out, all right, well, I have this you know, authentication or authorization to the services within Azure, the metadata services, and I have these permissions to spin up whether it be new nodes or load balancers or what have you. So all of you are fairly familiar with it if you've used AKS engine. You know, and so we're moving that effort into cloud provider, SIG cloud provider, which will happen along the next. So we're actually going to wait until the KubeCons are done. We've created a proposal and submitted that to the steering committee. So the steering committee is essentially like the top level governing body for the Kubernetes community, right? So steering committee breaks into, you know, then there are SIGs and working groups and sub-projects within the SIGs. So if we're making a sweeping change that's going to affect a bunch of SIGs, we usually will draft a proposal, right? So we recently submitted that, and essentially what we're going to do is wait until this KubeCon is over and Shanghai is over to start doing that consolidation effort, because all the people involved in that will be at KubeCon speaking, right? So that will be moving over to SIG Cloud Provider. SIG Cluster API Provider Azure. Cluster API Provider Azure is an implementation of the Cluster API. The Cluster API is a means of doing declarative Kubernetes provisioning and lifecycle management within Kubernetes. So it's a kind of we're trying to solve a kind of a meta problem here, right? Like, what if I can? So the same way you might hear about the operator pattern, where like I want to be able to encode human operational knowledge to a set of Kubernetes primitives, we want to be able to try to do the same thing with instantiating Kubernetes, right? So the ability to so Cluster API Provider Azure is one of the implementations of that. I am one of the primary maintainers for that. So if anyone has questions about how that works,
I do.
Yeah. Not you. And so that will be moving into SIG cluster lifecycle. And then finally, the CSI drivers. So there are various CSI drivers that we use. So Container Storage Interface is that acronym. I know you're probably getting hit with acronyms all week. So the CSI drivers, so basically the drivers that figure out how to do storage for Azure File, Azure Disk, different things like that, those will be moving into SIG storage, and that's mostly done, actually. Yeah. So I think, you know, the last few cycles we've been working on getting that done.
And if you want it, there's the link to all the information about SIG Cloud Provider. So let's spend a few minutes just kind of reviewing the recent path. So we talked kind of about the organizational changes that are in the works. And I just, you know, for people who haven't been paying attention, let's do just a quick review, and you can ask questions later, no problem. So the main thing is, you know, the big lift is essentially pulling the cloud providers that are all implemented in Kubernetes into a separate release tree. Now, from a functional perspective, that buys you 0, right? right? Like you don't get anything new for that. What you do get is why am I failing the word? The word
Velocity.
I'm delinking
Yeah.
the release velocity of Kubernetes from the release of the cloud provider for Azure. So if you want to have bug fixes, if you want to add new capabilities or features, then we can release the cloud provider for Azure separately. Now that raises other problems because we have to deal with version compatibility matrix and all those things. So all the effort for pulling out of tree includes all of these challenges for all the cloud providers.
So does anyone know why we started doing that, or why it's kind of hard to do?
Is it worth? You want to dig into that real quick?
Real quick, right? So the idea is that right now, if you know the standard, like building a Go project, right now the things that we've created, the provider implementations that are in tree Kubernetes, there are a bunch of intertangled dependencies within those implementations. So what that means is before we can actually pull all of these providers out of tree, we have to track each of the dependencies across all of the providers. The providers have to work together to essentially, like, okay, we'll package util mount. That can't exist in the providers anymore. Like, if we're going to stage this out of tree, we have to figure out a way to move this out, right? So it's been kind of like quite a bit of effort at working together with all the cloud providers to really understand. And SIG Cloud Provider has done an excellent job at really mapping these dependencies, and then one by one, someone will say like, well, I've got package util mount, I'm doing this one, right? So this happened over the course of the last year or so, right? To get us to the point where we can finally say, so I probably should have put the link, but I did a PR which pushes the out of tree provider over to the legacy cloud provider implementation, right? So there is a staging repo. So basically we have like a bunch of Go, Witchcraft, and Bash scripts that take things from this staging directory within Kubernetes, and there's a publishing bot that runs nightly now that will take everything from the staging from that staging directory and move it into separate directories that you can then import, right? So the initial phase of moving things out of tree is being able to stage them in the staging repo, and then pulling out those dependencies one by one. Yeah. So just felt like riffing on that.
It's a lot of labor, that's for sure. So the next thing is that there is now a cluster API provider for Azure. That's like a new thing. Yes. Yeah.
So I want to make sure it's recorded. Big shout out to the few interns working on it at Platform 9. So the cluster API provider Azure started off as a project within Platform 9, intern project, and then we had, I think, Marwan at Microsoft. So another one of the Microsoft interns started working on it.
I did not know that.
Yeah. So
cool.
So we got it to a point where, they got it to a point where it was functional, and then I started looking around. I was like, this cluster API thing is kicking off. I need to make sure that Azure is also in the game. And I was like, wait, let's see if there's something that already exists, right? And there was, and it was pretty great. So we migrated into the Kubernetes repos. So it's an official Kubernetes project now, and right now it's a joint effort between the VMware staff and Microsoft staff. So the same engineers that you know and love that work on AKS Engine are the same ones that are working on Cluster API Provider Azure right now. Right.
Yeah. Another big step in the sort of maturity of all the cloud providers is to beef up the end-to-end testing, and essentially we've done that for the Azure cloud provider. In fact, one of the core contributors is in the room, standing in the back. Hey, Rita. and so now we're actually using AKS Engine, and we have the whole end-to-end test pipeline. If we've got a lot of tests, there's a lot of testing going on. You want more tests? Let's build some more tests and make sure they work great, and we identify early and often issues as Azure changes, as Kubernetes changes, and as the cloud provider changes. We've got to make sure that all this stuff is stable going forward.
So if there are any aspiring contributors to Kubernetes, or current contributors to Kubernetes, I think that I love saying it. I think that testing and docs are so important. They're often overlooked parts of the project, and we can use all the help that we can get. So if you're interested in getting involved in some of those efforts, documenting the cloud provider, building out testing for it, and it doesn't just have to be for Azure. Like so I also run release and PM. So if you want to talk about any of that stuff, feel free to.
So service identity is another capability that's been added to the cloud provider and become much more mature recently. I honestly, I don't know a lot about exactly how that's implemented. Do you have anything to add to that?
I mean, so we're also pushing towards a model of allowing a sort of a no provider or no auth situation, where right now the requirement for auth in Azure is kind of like, okay, well, I have a service principal, or I have managed service identity, whether it's external or node based, and we're kind of going to this model where being able to instantiate a node with no provider, essentially. So I think Cal is working on that right now. And the idea there is more security for your nodes, honestly, right? Sometimes like there are nodes that don't need to have authentication to the Azure services. So.
Yep. And then obviously we kind of touched on some of the stuff that's happening with CSI, and essentially the Azure Disk has gone to alpha. We've got the file drivers, and we've added support for many more of the SSD classes. I mean, essentially, as Azure adds more and more SKUs and ways in which you deploy things, those need to be supported then in the cloud provider. And so we're just making sure we keep up with Azure as we go. Same kind of thing goes for the load balancer configurations. We're trying to keep up with the pace of innovation in the underlying platform. And then a big thing in Azure has been the virtual machine scale sets and the very powerful capabilities that provides around managing a large number of VMs with a common kind of metadata set. And so supporting those across all of Kubernetes is like one of the key capabilities that the AKS needs, that all of you, I expect, will need as well.
So if you're familiar with like virtual machine scale sets, you know that the API for building virtual machines versus virtual machine scale sets are slightly different. Right. So there was a lot of work done to essentially, like, well, one, we've got to build it into Kubernetes. We've got to build the idea that, one, you can instantiate nodes, but you can also instantiate the idea of like node pools, right? So working on refactoring all of the Kubernetes code to be able to support things like that has been an active effort over the last like year and a half, I would say. Yeah,
absolutely, and it's actually a key capability that's required to add additional operating systems, to add additional architectures. Right, so you need to be able.
People looking at Windows support, right? That's kind of part of how we get it.
I wonder why we might want to do that, right? But there's also other considerations that are really important. Like you may want to have a pool of machines that have, all of these machines have a certain kind of GPU, for example, right? And so those kind of management concepts are now being built into Kubernetes itself, and SIG Azure is one of the places that's driving that.
And then you'll see a lot starting to happen around node topology, or not just node topology, but resource topology in general, right? So the concept of like, I want to, if I'm building a standard data center, I have to build, I have to rack, I have to power, I have to run storage, I have to, do all the networking, right? So there are a lot of things involved in that, and then it gets more complex when you start to look at a cloud provider scenario. And then when you start to look at, okay, well, I'm running multiple clusters and multiple cloud providers, right? I need a concept of, if I build a node and I build storage, I want to make sure that the node is close to the storage that's going to be attached to it, right? Exactly. So that's all code that has to be written. That's all fancy annotations that have to be built into it. And so there's a lot of work happening there. Definitely on the storage side, SIG storage. So there are
cluster lifecycle.
And cluster lifecycle.
So what are we doing next, right? What are the big things? I think we've alluded to a lot of this already. So we've already gotten pretty far with moving the cloud provider out of the Kubernetes tree, and it's functional. It works. There's a few last steps to complete there that are being tracked in this issue. The big thing that's missing and isn't tracked in that issue yet is documentation. So today you can go play with the code or look at the code or try it out, but there's not a lot of guidance for how to do that.
Choose your own adventure.
Yeah, we need to fix that. That's definitely a big deliverable for us coming. And I think that from that point, I wanted you to talk about the
Yeah. So you know,
provider.
yeah. So from
Cluster API.
from the perspective of a cluster API maintainer,
Yeah.
again, we need help. Like I think we need help in every portion of the project, right? So if you're talking to a SIG chair or SIG technical lead this week, ask them how you can help if you're interested in contributing to Kubernetes. So you know, from the cluster API provider perspective, I'm actively recruiting. So if you're interested in working on that, let me know. So we have this idea of a V1 Alpha 1 implementation of cluster API. And the V1 Alpha 1 implementation is basically like the shift from the shift into using CRDs to manage some of this stuff, right? So what we're trying to do is every time we cut a version of Cluster API Azure, we want to make sure that that stuff is compatible, like SemVer compatible to the upstream Cluster API proper, right? So continuing to work on that implementation, we've moved past kind of like our MVP baseline state, and we're moving more into this preparing for V1 Alpha 1, V1 Alpha 2 push, right? So V1 Alpha 2 in Cluster API, you might see a transition over to like webhook based operations. So.
Yeah, so I think, you know, essentially there's a lot of moving parts, right, is kind of what you've heard. And so what we're initiating here is the idea that we need to create a virtual planning event. We need to get all of the sort of different pieces together. And in a way, you know, it's hard because no matter how you cut the organization, there's always going to be lots of cross-SIG dependencies. And we need to find a way to get all of those things together to align them and make sure that we've got the right efforts and investments in the right areas. So we're going to have a kind of a planning session sometime after the summer. Right? We don't yet know when exactly, and we're totally open to ideas and suggestions about when and where and how that would happen. You know, my first idea is that it would be just a virtual event. We'd get some pre-planning done, like, you know, what are the big questions that everybody wants to answer across all of the SIGs, and get everybody contributing to that, and then we'd organize pre-work and preparation for that, and then we'd have a session where we work through all of that and come out with a set of concrete roadmaps for all of the different dependencies. And that's the high-level idea there. And with that, I think we've said this a bunch of times, but yes.
Come join us.
Yeah. So all of those people who said they've never been to a SIG Azure set meeting, please start coming. We do have a challenge. We may end up having to do 2 SIG Azure meetings because we actually have a significant set of contributors who are in sort of Far East time zones, and a significant set who are in North America, and I'm hoping that we're going to get a significant set who are also in Europe.
Yeah, folks, come on.
Yeah. So,
come play.
So we need to figure out probably 2 meeting times, and we might alternate like every other week.
So yeah, so most of the Microsoft days are Pacific time zone. I'm on Eastern. So bringing APAC into the mix is going to be an interesting one. Yep. I don't think that we can find like an amenable meeting time.
There's not going to be one.
Yeah, exactly. Without doing 2. So that'll be coming soon.
Yep. And so we do maintain a project board in GitHub. So this is a great way to kind of understand at least what the people who are active in the SIG believe are the things that need to be happening. And so one really concrete and kind of easy asynchronous way to understand what people are paying attention to and have your voice heard is to go into the project board and add your comments to issues. Like, speak up.
I think it's broken.
Right.
You haven't fixed it in years.
Yes, I'm sure I will hear that, and that's great. And so with that being said, we want to just invite you to another session that's happening later this week. So on Thursday at 1400 in the other building. Is a deep dive where you get to hear Stephen again, but also Lockie.
I'll be yapping again. And Lockie Evanson, one of the principal program managers at Microsoft as well, works closely with Craig. We will be doing a demo on Cluster API Azure, as well as going a little deeper into some of these topics. So.
Absolutely. And so with that, we want to open up for questions. Who wants to
Rita?
go first?
Hold on.
Should we handle Mike?
Thanks.
Oh.
Well, this provider API thing, is it going to make the clusters less bound to provider. So I'm thinking, if I have a setup to run my cluster in Azure, but I would also like to run the same thing in Minikube to test it.
Mm-hmm.
So I don't want to hard code that I use Azure File
Right.
for share, for instance.
Right.
Is that plan?
Yeah. So actually, for the provider implementations for Cluster API, the bootstrap phase of the provider is actually can either be done via Minikube or via Kind. So if anyone has never heard of Kind, go check it out. Like, Kind is really cool. The bootstrap process is infinitely faster. One of the issues that we run into is exactly that, right? The way we build Cluster API implementations has to be done in an agnostic way, right? However, there are only so many things that you can make agnostic without realizing that like this is provider specific implementation,
Mm-hmm.
right? Right. So yes, but there's a point at which it is provider specific, right? So right now there isn't a.
There's always going to be separate configurations and timings and things that aren't going to work the same across the different clouds. But our goal is to minimize those things, right?
Yeah.
Not to maximize those.
Perhaps one more question in the
Sure.
same theme. I'm also thinking, I hear a lot about KubeAdmin,
Right.
and I have not tried it, but I feel it's similar to AKS Engine in some sense.
Yeah.
So can you use KubeAdmin to do things on a cluster created by AKS Engine?
So I'll take that. So KubeAtom is a very sort of generic infrastructure related tool, right? So it abstracts directly from the IaaS API. Today, what AKS Engine does is it creates ARM templates, which are basically an Azure specific implementation of that abstraction. And so we're at a point where we're trying to decide, honestly, whether or not we need to consolidate those things or they need to remain on separate tracks because they have different use cases. And that's actually the analysis that I'm in the process of doing actively over the next several weeks. Please, let's talk about that more. I'd like to understand the perspective. What would you like to see from a consumption perspective? How would you like that to work?
So the funny story, the Cluster API provider for Azure actually started off using ARM templates as well, right? So very similar, different provisioning process, but the end artifact that you get out of it is the same. So right now we're for Cluster API we're using KubeADM as the provisioning tool.
Yeah,
and we may see, as Craig mentioned, we may see a convergence of those efforts, right? Because that's kind of the reason we have the AKS Engine engineers working on Cluster API as well. There's possibly going to be I'm not going to speak for Microsoft, but there's possibly going to be a melding of worlds.
For me.
Yeah.
Yep.
Hold on, so we can get it on. Yeah, we can get it on video.
So the cluster API, basically, where do you see the line being drawn between the different cloud providers and different cloud providers' capabilities? In example, scale sets versus VM scale sets,
Right.
or virtual machines in all clouds, like.
So it's exactly right there. AWS doesn't have the concept of virtual machine scale sets, right? But they do have the concept of a node or an instance, right? So like there's a mapping of what the two main objects that you kind of manipulate within Cluster API are the cluster object and the machine object, right? So how you define a Kubernetes cluster is essentially the same across all providers, right? But how you define a machine within those providers is slightly different, right? So, figuring out how to attach storage to the machines, figuring out how those machines would authenticate to certain things, right? And then we've got all these things that build up or what you consider a Kubernetes cluster or a production-ready implementation of a Kubernetes cluster, right? So on a cloud provider, might have a bastion host and a load balancer, and the load balancer, and then a set of security groups within the cloud provider, and then a set of machines under those security groups. And on the AWS side, you've got VPCs and subnets, and on the Azure side, you've got VPCs, but and then you start to consider you've not virtual networks, excuse me. So on the So there start to be differences in those implementations when you look at the fact that for a virtual network in Azure, the way you handle security groups is slightly different, right, compared to AWS. Right, AWS you can attach security groups and you can stack security groups onto sets of machines, right? Whereas in Azure, the security groups can be NIC bound or they can be subnet bound, right? So that's a implementation detail that we have to handle within the provider-specific implementation. And then the same when you look at things like load balancers, right? We handle load balancers entirely different between the two providers. And I'm just using AWS as an example, but the same is true for kind of like all of these providers, right? So the line becomes like, the cluster is definitely kind of homogeneous across providers, and then the implementation-specific things start to happen around the machine layer.
Yeah, so I guess the way I like to think about it is that the management actions, like your intent, can be the same across, but the implementation has to be different. There's no way around it. You know, I don't think you can have common configuration that will work across all of them.
So basically what you're saying, there is no way we will see like VMSS support in the cloud API, cluster API, just because it deviates too much from other cloud implementations of managing multiple VMs.
Well, I can't predict the future, but it's quite possible that other cloud providers will also implement a similar construct for similar reasons, and I don't see why that wouldn't happen, in which case it starts to make sense to have an abstraction at the higher level.
So there are additional abstractions like the machine deployments, machine sets, right? Mm-hmm. So they're like the rabbit hole goes a little deeper in cluster API. This is kind of like the broad strokes. But you know, you consider the VMSS versus something like auto scaling groups in AWS. Again, different implementation, right? So how we have to handle it within the cloud provider implementations are going to be slightly tweaked. What we try to do is right now we're not looking too intently on building out VMSS, only because VMSS is a little antithetical to the whole like concept of a single machine. Right? Mm-hmm. So until we figure out a way to open up the concept of multiple machines running in the context of like VMSS, we probably won't do it for cluster API. No.
Other questions?
Questions? All right.
Thanks for taking the mic.
So from the SIG point of view, what is the right use case to use AKS engine versus AKS?
I'll take that one. So, you know, it's a question of what you want to manage fundamentally, right? Like, do you want to manage the master nodes in the control plane and their upgrade path? And do you need to have, you know, essentially intimate control over which features are enabled versus not enabled? Do you need to add in your own capabilities? Then AKS Engine is really your only path. AKS is a managed service where, you know, it's up to us when we add new capabilities into the control plane, and you just don't have access to the management network, right? It's entirely protected from you for good reasons, and you know, it's really a question of your use case. So the mental model that I tend to use is if you are providing a managed service for whoever your users are, you know, whether you're a service provider yourself or you can think of yourself as a service provider within a company, and you need to do things that are outside of the scope of AKS, the managed service, then AKS Engine is a great tool to help you manage, you know, to at least get your clusters up and running and manage the life cycle of those clusters. You know, if what you want is a utility and you want to be the consumer of a service, then AKS is the solution. Does that help?
Yes, thank you.
Great.
Okay. Rita, yeah.
I have a quick question. Like, I wanted to understand how everyone's deploying things to Azure. Like, what tool you're using. Are you using AKS?
Oh, you came in late. We asked that at the beginning.
Awesome.
So the majority of the crowd is either using AKS Engine or AKS.
Yeah, I was very surprised to see that very few people raised their hand when I asked if people were rolling their own, and almost everybody is running clusters on Azure.
Yeah, I don't think anyone raised their hand for rolling their own.
No.
Right?
Did anybody? No? Okay, that's Very interesting. I was. Oh, you are? But you came in later too. Cool. Other questions? No? Okay. Well, I will be actually headed to the Microsoft booth. I've been asked by marketing to continue any conversations that want to be happening. We can have them there. But I'll also hang out here for a little while too. And
I'll be around. I'm on Twitter too. You can follow me on Twitter. So.
yeah. Well, thank you guys very much. I really appreciate the questions, and looking forward to seeing you guys in SIG Azure.